Cold hydrogen clouds discovered inside superheated Fermi bubbles at Milky Way's center by Tracy Peak. North Carolina State University, edited by Lisa Locke. Reviewed by Robert Egan. Editor's notes credit NSF, AUIN, SF, NRA, OP. Vostein researchers have found clouds of cold gas embedded deep within larger superheated gas clouds or Fermi bubbles at the Milky Way's center. The finding challenges current models of Fermi bubble formation and reveals that the bubbles are much younger than previously estimated. Reaching about 25,000 light-years in each direction from the galaxy's center, spanning a total height of 50,000 light-years, but we do know that it was an extremely sudden and violent event, like a volcanic eruption, but on a massive scale, says Rongman Bordaloy, associate professor of physics at North Carolina State University and corresponding author of the research published in the Astrophysical Journal Letters. The Fermi bubbles are enormous structures of hot gas that extend above and below the disk of the Milky. Fermi bubbles are a relatively recent discovery. They were first identified by telescopes that see gamma rays in 2010. There are different theories about how it happened. Finding those clouds within the Fermi bubble is like finding ice cubes in a volcano. These measurements were twice as sensitive as previous radio telescope surveys of the Fermi bubbles and allowed them to observe finer detail within the bubbles. Usually within a few million years, a timescale that aligns with independent estimates of the Fermi bubble's age. Bordaloy says, it would not be possible for the clouds to be present at all if the Fermi bubbles were 10 million years old or older. Bordaloy and the research team used the U.S. National Science Foundation Green Bank telescope to observe the Fermi bubbles and get high-resolution data about the composition of the gas within and the speed at which it is moving. The clouds lie along a sightline previously observed with HST, which detected highly ionized multi-phase gas, ranging in temperatures from 1,000,000 to 100,000 Kelvin, which is what you would expect to see if a cold gas is getting evaporated. Most of the gas inside the Fermi bubbles is about 1,000,000 degrees Kelvin. Sign up for our free newsletter and get updates on breakthroughs, innovations, and research that matter daily or weekly. However, the research team also found something surprising: dense clouds of neutral hydrogen gas, each one measuring several thousand solar masses, dotted within the bubbles 12,000 light-years above the center of the Milky Way. The findings provide a crucial benchmark for simulations of galactic feedback and evolution, reshaping our view of how energy and matter cycle through galaxies. These clouds of neutral hydrogen are cold relative to the rest of the Fermi bubble, says Andrew Fox, Aura astronomer at the Space Telescope Science Institute and co-author of the paper. They're around 10,000 degrees Kelvin, so cooler than their surroundings by at least a factor of 100. These clouds weren't here when dinosaurs roamed Earth. In cosmic timescales, 1,000,000 years is the blink of an eye. Their existence is surprising because the hot, high-velocity environment of the nuclear outflow should have rapidly destroyed any cooler gas, says Jay Lockman, an astronomer at the Green Bank Observatory and co-author of the paper. Just as you could see the motion of the wind on Earth, unless there are clouds to track it, we couldn't see the hot wind from the Milky Way but can detect radio emission from the cold clouds it carries along. Computer models of cool gas interacting with hot outflowing gas in extreme environments like the Fermi bubbles show that cool clouds should be rapidly destroyed. What makes this discovery even more remarkable is its synergy with ultraviolet observations from the Hubble Space Telescope, Bordaloy says. The team was also able to calculate the speed at which the gases are moving, which further confirmed the age. Discover the latest in science, tech, and space with over 100,000 subscribers who rely on phys.org for daily insights. These gases are moving around 1,000,000 miles per hour, which also marks the Fermi bubbles as a recent development, Bordaloy says. We believe that these cold clouds were swept up from the Milky Way's center and carried aloft by the very hot wind that formed the Fermi bubbles. This discovery challenges current understanding of how cold clouds can survive the extreme energetic environment of the galactic center, placing strong empirical constraints on how outflows interact with their surroundings. More information, Rongmen, Bordaloy, et al., a new high-latitude HI cloud complex entrained in the northern Fermi bub,